There are three types of reasoning: intuitive, inductive, and deductive. Let's first look at intuitive. Intuitive reasoning is a sudden jump to a conclusion based on instinct or intuition. For example, I look at this triangle and assume that all triangles must have three sides of equal length. But intuitive reasoning does not always lead to correct conclusions. There are many types of triangles. Intuitive reasoning is a very important part of the learning process. As we become more familiar with a topic, we often are more likely to have correct intuition. Since we know that intuition does not always lead to correct conclusions, we have to be careful to support it with another type of reasoning. Inductive reasoning is the process of reaching a general conclusion based on specific instances or examples. Inductive reasoning is based on past experiences or experimentation. For example, I can look at many triangles and see that they all appear to have three sides of equal length, and therefore conclude that all triangles have three sides of equal length. We can see that inductive reasoning can still lead us to incorrect conclusions. Let's consider continuing our example by looking at more triangles. We can look at 10, 100, or even 1,000 triangles that all have three sides of equal length. But as soon as we find just one triangle that does not have sides of equal length, our conclusion is shown to be false. The triangle that does not follow the rule is called a counterexample. No matter how much evidence we have to support our claim, all it takes is one counterexample to show that our claim is false. Let's look at another example of inductive reasoning. I look at many parallelograms and see that all of them appear to have opposite sides that have equal length. In this case, no matter how many parallelograms we look at, we will never find a counterexample. That is because our inductive reasoning has led to a correct conclusion. We cannot base this on inductive reasoning alone because it is impossible to look at all parallelograms, but later in the course, we will prove that this conclusion is true. When we use inductive reasoning, we need to look at enough cases and see if our conclusion holds. Even though we cannot prove our conclusion using inductive reasoning, the more evidence we have, the stronger our argument will be. Deductive reasoning is the process of reaching a specific conclusion based on general principles that we know to be true. When we carefully prove a conclusion using deductive reasoning and valid principles, we know it has to be true. Therefore, we can say no counterexamples exist, and our conclusion holds in all cases. For example, we can use properties of a parallelogram to show that both pairs of opposite sides are equal in length. Therefore, for this parallelogram, we know that the left and right sides will have the same length. There you have it, three types of reasoning.